Welcome to a nostalgic math chat. We are looking at IEB paper 2, November 2023, and we're looking at question 4 of that paper. So in the diagram, the points A, B, and C all lie on the circle with center O. Line OA is parallel to CB, okay, and that is also indicated on the diagram. Angle OAC is 25 degrees. Then we're asked to work out the size of COA. So COA, just that guy. Ooh, too thick. Okay, so what stands out to me immediately about COA is that is an isosceles triangle because OA and OC are radii, which means they are equal in length, and we have this angle, so that means we have this angle because isosceles triangle, which can help us then work out that angle. So let's write all of that down. So OA is equal to OC, and that is because they are radii, and so therefore a triangle COA is isosceles because OA is equal to OC, and so that means angle they've given us little numbers, so angle C1 will be equal to angle A because base angles of isos triangle OCA. So that means C1 is also 25 degrees, and so therefore angle O will be equal to, or rather what they've said, let's name it in full. So angle COA will be equal to 180 degrees minus 2 times 25 degrees, and that is because of course write your reasons next to your statement, don't do this. Angle sum of triangle OAC, right, and that will give us 130 degrees. Okay, let's see if the memo is tracking along. I closed the memo. Oh dear. So question 4. Hey, where's question 4? Oh, okay, so yes, we get 130 degrees, perfect. Then we're asked to determine the size of O1. Okay, so I'm just gonna write down what we've found out so far. So these are equal. This is also 25 degrees, and this whole angle is 130 degrees. Okay, so I feel like if I can find the size of O2, which is alternate with this guy, then I can find O1 because I know the size of the whole of O. So okay, I know that B is alternate with this guy, and this guy is alternate with that guy. Man, how does that help me? Well, do we have any angle at center situations going on? Oh yes, we do. So I first looked at that angle at center, and does this chord subtend anything at the circumference? But it doesn't. So then what I looked at next was this angle at the center, and does this chord subtend anything at the circumference? And it does. It subtends that angle over there. right? So how does that help us? Well, it helps us because it tells us that O2, oopsie, O2 is double what this angle is. And what is this angle? We said it's alternate with this guy. So, perfect. We can then work out O1 from there. So let's write this down. So, we know that angle C2 is equal to angle A because alternate angles on the parallel lines we were provided with, which gives us, yeah, C2 is 25 degrees. And then we know angle at center, so angle O2 is equal to 2 times angle C2 because angle at center, right, is twice the one at the circumference. So that'll be 2 times 25, which is 50, right? And then from there we can work out angle O1 because we know that the whole of O is 130. So we can then work out O1 is equal to 130 degrees minus 50 degrees. Well, can be more specific. Minus O2, which is 130 degrees minus 50, which is 80 degrees. Yeah, I feel like, I don't know if there's a shorter way to do that. Because alternatively, we could have said, we know what O2 is, therefore we know what this is, and this is isosceles, well, just by virtue of it being a triangle. Yeah, because we'd know 50, 50, so then we'd know that this is 80 using angle sum. But yeah, let's see if the memo has a different approach. So they also use alternate angles to find C2, yes. Then they say C1 plus C2 is 25 degrees. Well, sorry, each of them is 25. C1 plus C2 is equal to B because it's an isosceles triangle. Oh, so pretty much what I just said now. So B is also 50, and therefore O1 will be 180 minus this 50 minus that 50 as well, so getting us to 80. Yeah, potato, potato.